So hello guys, in this video we will talk about quick sort algorithm. So this is a sorting algorithm. Like in previous video we'll talk about merge sort, which is based on divide and conquer. So this algorithm is also based on divide and conquer. So in this, what is the theory behind it? So in this, first we choose one pivot element, and that element can be chosen the first element, last element, middle element, or randomly any element in the list. Then what we do, then array is divided in such a way that all the element to the right of the pivot element should be greater than or equal to the pivot, and on the left they would be smaller. So like if I say this, so if I choose pivot 5, like the last element of the array, then all the elements should in the left like would be smaller and all in the right will be larger. Like so here 1 is here and 10, 7, 8, 9 is here and 5 is here. So all in the right are large or in the left are small. So if you sort this array, the final result will come like this. So we so the final result will come like this. So we by doing pivot by choosing one pivot element and all the element in left are small and right are big, we are correctly finding its index. So like 5 index is correct here, its index is 1, and here after complete sorting it is also 1. So like this, then we recursively call this quick the function we have defined like the here uh, uh, this quicksort function. This will repeatedly work on this part and this part until our complete array is sorted. So this is our function. So let's see how this is working. So this function, there are two parts. One is the partition part and another is the quicksort algorithm. So first, what is the partition part? So this partition function takes a last element as a pivot, places the pivot element at its corresponding position in the sorted array, and places all the smaller element, all the smaller than the pivot to the left of the pivot, and all greater element to the right of the pivot. So this is this things. This is its correct position in sorted array. All in left are small, all in right are big. So there are three argument array, low and high. So let's say this is our array. So and this is our array, and if we are checking here, so the low part it is 0 and high part is n minus 1. So here we are taking low as 0 and high as n minus 1 last index. So in our case n is 6, so 6 minus 1 5. So this is the thing. So then we defining I. So I is equal to low minus 1 means low is 0, so 0 minus 1 is minus 1. So this is minus 1. Pivot element is array of I. Array of I means last element, so pivot element in our case is 5. So this is our pivot element. Then we are doing one for loop for j in the range of low to high. So low is 0 and high is 5. So in 0 to 5 means 0, 1, 2, 3, 4. These are the different value of j that it can take. So then it starts. An array of 0 is less than pivot. So 10 is less than 5, so it will not correct. So this is not run. Then j is incremented by 1, 7 is less than 5, so it will not correct. Then it will increment by 1, 8 is not less than 5, 9 is not less than 5. Then it will come to here. So 1 is less than 5, so this condition is correct. So at j is equal to 4, we get this condition. Then this I will increment by 1. So initially I is minus 1, so will increment by 1, so now it will become 0. So now I will become 0. Then what we are doing, so we are swapping like array of I and array of j, we are swapping. So in this case we have I is equal to 0 and j is equal to 4. So I is equal to 0 element is this and j is equal to 4 element is this. So we are swapping. So after swapping it will become 1, 10, 7, 8, so sorry 1 7, 8, 9, 10 and 5. So 1 and 10 position, 1 and 10 are swapped according to this, and then uh, after completing for loop, we are coming out of this and we are doing this. So array of I plus 1 and array of I is equal to, so we are also swapping, like now I value is 0, so I plus 1 is 1, so array of 1 is this, so array of 1 is this and array of I is this, so we are also swapping these two. So now it will become 1 5 8 9 10 7, so this will become like this, so we are correctly in, or if we take our sorted list, so it will look like this finally. So here its position is index is 1 and its index is also 1, so this is correct. So we are correctly finding uh, the index of the pivot element, and all the element in the left are smaller and all the element in the right are bigger. So this part is done. Then we are doing the quicksort algorithm like this. So if low is less than, then here low is 0 and high is n minus 1. So in our case initially we will take, so low is 0 and high is n minus 1, high is 5. So this is correct. So then pi is the partition index. Array of p is now at the right index, so we have done this after doing the partition function. Our element 5, which is our pivot element, is its right position, and this is giving its index, so this will returning I plus 1. So in our case, what is the value of I plus 1? So in our case, after doing partition, we will get 1, so 1 is the correct index of this 5. Then we are what we are doing, so from 0 to 1 minus 1, so from 0 to 0. So from here we are doing quick sort on this left part. This is left part, we are again applying quick sort on this, and we are again applying quick sort on this. So this will done recursively, and finally we will get our final result. So in this way, this is working. Next, we will see its implementation in Python tutor. So there you can visualize how all these things are happening. So let's see that part. So hello guys, this website is very good for visualizing the code. So this is Python tutor. You can take note of this. So here I uploaded my code of quicksort algorithm. Now let's we will see how this array is sorted using this algorithm. So first we are defining partition function, then we are defining quicksort function, and next this is our array and n is equal to 6. Then we are applying the quicksort algorithm. So it will calculate low is equal to 0 and high is equal to 5, and then if this is running this loop, so first it will calculate what is the partition uh, of our this partition function. It will run. So I value is initially minus 1, pivot element is 5, we are choosing the end of the list element, and j is start from 0, and it will compare, like this for loop will run, and in the end at j is equal to 4, I will increment by 1, so I will now become 0, and here we are swapping. So like here you can see in this yellow color, 1 and 10 are swapped. Next we are swapping 5 and 7 and returning I plus 1. So I plus 1, so pi value is 1. So now this value is 1, which is the correct index of our pivot element 5. So we find the correct index of our pivot element in sorted list. So and in the left of this all are small, in the right all are big. Now again this quicksort recursively run on the left part. So here low and high both are 0, and this will this, and then it will run on right part. So it will do the same thing, like so here you can see that 7 is if you can previously see, 7 is the last element of this right array, 8 9 10 7. So means 7 is the uh, now last element. So it will, after running, it will find its correct position as 7. So next again we will run recursively. So our now so now low is 3, index 3 and high is 5. So again this is running on this part 3 to 5. So now its find is 8's correct position. So now after running all that part, 8 is its correct position. Now again we are applying the quick sort on this, and now low is 4 and high is 5. So on this part, so like now 9, which is the last element which find its correct position, this, and now last part is remaining. So here it is completed, like we find the our sorted list. So next we are printing the elements and this is done. So here we printed the element, sorted array is this. So in this way this is running. So hope you find this helpful. So if you find this helpful, please like and subscribe. We will meet in next video.